Hello, my name is Aaron Creech, and I'm a Solid Edge Application Engineer at PROLIM, located here in Cincinnati, Ohio. Today we're going to discuss advancements made with the 3D printing features within Solid Edge 2020. We're going to talk about 3D print technology, common 3D print file types, preparing your model, validating your model, and exporting your model to either your own 3D printer or an online 3D print service bureau. So let's first start with a little bit of 3D print history. So in 1984, the first 3D printer was developed. In 2005, the open source movement hit. And then in 2009, first personal 3D printer was sold. So with the rise of degenerative design concepts, parts are becoming more and more complex in shape. Shapes that were previously very hard and very expensive to manufacture, complex shapes can now be quickly created and super lightweight and cost much less to produce. So with the recent reduction in printing materials, manufacturing, and technology costs, the U.S. 3D printing industry hit $9.9 billion in 2019 and is projected to hit $34.8 billion by 2024. Solid Edge has recognized this rapid growth and jumped to the opportunity to integrate a simple 3D feature within Solid Edge 2020 and beyond. These markets are most popular in the aero, defense, engineering, healthcare, consumer products, and automotive industries. Now we're going to look at 3D common file types within Solid Edge. So the original STL format, or stereolithography, or even standard triangle language, is the original file type that was first created to translate CAD data into a third-party 3D printing software. It works by creating a series of small rectangles to produce edges and curves of a model. This file type only maintains the surface geometry of a model without any representation of the color, texture, or model attributes. Specifies in both ASCII and binary files. Binary are more common as they are more compact. File type is ideal for quick, low-quality 3D prints. The 3MF file type, 3D manufacturing format, is an XML-based open-source format designed specifically for the additive manufacturing processing. This file type includes mesh, material, color, and texture, all directly from the model geometry and then contained in one model file. The 3MF file size is dramatically smaller than an STL format as well. Ideal for more complex, detailed 3D prints and large files. Now let's go into Solid Edge. Now we'll go ahead and open up a previously created 3D model. And as you can see, it's a pretty simple machined part. It's got a couple of cosmetic threaded mounting holes and also has a couple of cosmetic threaded studs. So let's go ahead and explore the new 3D print tab that's new within Solid Edge 2020. So now you can see that there's a custom ribbon bar for all of the 3D print functions. There's not a lot, so this is going to be a pretty basic tutorial. But we'll kind of explain each one of the groups. So we have a clipping plane where we can create quick section views of the model. We have the prepare group, which contains the physical threaded conversion option. We can delete voids. We can reorientate the part. And then we have the validate group, which contains the wall thickness and overhang commands. And then finally we have the export command. First we're going to look at the set planes. We'll go ahead and create a quick cutting plane. I'm going to activate my base reference planes and select the right plane. I'm also going to just select to create my plane in that same general area, the center of the part. Now I'm going to snap to the back of the part. And you can see we've got a quick section view of the part. Again, a very basic part, not much to see here, but if you had a more complex part, this would be very helpful. So we can also activate and deactivate this at any time. So we just click on the on, turns back on, and we can also do a Control D, which will toggle us back and forth between the views as well. Next, we're going to look at the physical thread option. Please keep in mind with Solid Edge 2020 Maintenance Pack 3 and above, the physical thread option for the hole and thread command bar is disabled by default. This is due to performance issues resulting from the creation of threaded geometry. So you may need to get with your system administrator to access the options XML file to enable this command. So as you can see from the quick toolbar here, there's not a lot of features here. So we can either select the holes that we want to convert from a cosmetic to a physical thread by manually selecting each one. is that. Or if we cancel, go back in, we also have the option to select all. So go ahead and select all. It recognizes all the threads to be converted, and for some reason if we wanted to deselect any of these, we could do this so at any time by shift select. But we want to add these to this, so we'll go ahead and reselect, hit accept. As you can see, there is some performance delay with this option, especially if you had a part with hundreds of holes. So you can see we get this physical thread pop up. We can view the log of what was created. So as we can see, all of our holes and our threaded studs have successfully converted to a physical thread. Go ahead and close that, hit OK. And now as you can see, our threads are now physical. They don't have the mapping of just the image of a threaded feature as the cosmetic feature is described. So that's the threaded feature, and this is great for 3D printing purposes. So if you wanted to physically mount this to a part or mount hardware to it, you now have the capability of doing that. Next, we're going to look at the delete voids command. So this is a great command for parts that are coming from native 3D CAD packages or scans. Sometimes in the translation, some parts don't get fully solved, or some areas don't get fully solved. So sometimes that results in some voids or some oddities within the model that need to be corrected. So if we go ahead and select this delete void check, we can see immediately that we've got a cavity in here that we don't want. So this may be part of your 3D print specifications. You may need this here. Otherwise, I'm not going to need it here. I just wanted to show to represent kind of the principle of deleting a void. Now we're going to explore our options. So here we have the ability to change the color of the body versus the void. And we're going to go ahead and select this void, this area to be voided. Computes, recalculates, and as you can see, now the void is gone and the part is completely green. No voids found. So we'll go ahead and cancel that. Now we're going to get into reorientating the part. So based on experience, I know if we print this part here, we may need to add in some additional supports to maintain this bottom surface as it's being printed. So I know that I want to kind of reorientate this part in comparison to how I've created it. So it's pretty simple. We'll activate our reorient command. And now this gives us a representation of a 3D printing bed. So as you can see, we've got our primary part border here. This is going to basically give us the envelope of the part. And then on the outside, we've got our envelope of a default 3D printer bed. So to explore this a little further, we'll go into the settings. And again, this is where you would establish your printer size. Then you can also designate your display resolution as well. I'm going to select medium. I'm just going to keep the default. This is the default based on the parameters of the size of the part, so this will adjust as your part expands or gets smaller. So I want to rotate this part 90 degrees, so I'm going to go into the control to reselect rotate. I'm also going to activate my base, and now I know I want to rotate this 90 degrees about the x-axis. So we'll go ahead and adjust that to 90 degrees. And you can see the part rotates. The red is representing that part of the part is below the printer bed. So an easy way to solve this would be to settle the part. So select the settle command, which is the second to the right. And now we're back on top of the surface of the bed. So this is going to give us an ideal positioning as we generate through the 3D printing process. So as you can see, once we exit out of the reoriented command, the model goes back to its original position. Keep in mind that is set, and we will explore that as we continue through the process. Now we're going to validate the model. So this particular part doesn't have any hollow walls. There was a void that we deleted in the center, but that was just for show. So unfortunately with this part we don't have any wall thicknesses that we need to maintain, but this is where you would select your wall thickness. As you can see, we've diverted back to our reorientation that we previously set. So the default is a 20 millimeter wall thickness, and clearly that's probably not going to work. So this is where we would determine the wall thickness. If we had that, options again are pretty much the same as set forth before. We can change the color of what our body is versus our minimum wall thickness. So fortunately we don't have anything here to adjust, so we're going to go ahead and cancel out of this command. Then we're going to go back to 3D print, and then we're going to do the overhang. So the overhang is going to calculate the model based on the positioning of the part to determine how much extra material is needed to support the body as it's being built in the 3D printing environment. So we'll go to the overhang. It does a quick compute of the part. So now we're going to look at the maximum angle. And again, we've got some settings in here that we can manipulate. Again, they're just the standard colors. So we're not going to, we're just for show, we're going to keep the maximum angle at 30 degrees. And we're going to go ahead and calculate this to kind of get a visual of what we're looking at here. So we can see, based on this positioning of the part, it's not ideal for us. So we can actually toggle the body off. So let's go ahead and toggle that off. So now we got a pretty good idea of how much extra material is going to be required to support this 3D model. So you can see there's quite a bit in the threading portions of the model as well. So let's go ahead and look at adjusting some of this just to see if we can reduce the amount of extra material needed. So let's go ahead and increase this to maybe 50 degrees. And you can see we're now starting to see some of the reduction in the threading support features. So let's keep adjusting that. So increasing it to 60% got rid of all of the hole features needed. Now we're just left with a studded thread feature. So let's go ahead and crank this up a little more. 70, you can see we're reducing it each increment. 80, I think we can go up to 90. And that's about it. So I think we can, 90 degrees our highest angle there. So we'll go back to 90. And that's going to be about as reduced as we can get it. But again, as you can notice, this part is now configuring it based on the original orientation of the part and not that rotated about the x-axis as we did previously. So let's go ahead and cancel this, and we can kind of compare this to the original. So let's go back into the reorientate, and we're going to do the same thing again. We're going to select the rotate option, and we want to rotate about the x-axis at 90 degrees, and then we're going to resettle the part. Now we'll go back into the overhang feature. Now we're calculating it based on that angle. So we'll go ahead and recalculate again. We'll leave it set at 50 degrees for now. So now you can see there's much less added extra material required to print this part. So we'll toggle the view off. And now we'll start working on reducing the features here. So we'll go to 80, we'll go to 90, and we can see that we've got very minimal material left over, and kind of get a comparison of what the part looked like in the other orientation. There was a lot more red required to print that part. So this is our ideal printing position. So we'll go ahead and hit cancel. So now we very quickly created a clipping plane. We prepared the model and we validated the model. So the next option is to export. So let's go ahead and look at the export feature. So we're going to go ahead and select the export command. And we're going to go ahead and save this just for comparison purposes. We'll start with an STL. And again, previously we discussed the differences between the STL and the 3MF file types. And as you can see, those are the only two available in Solid Edge. So we're going to convert both. So let's go ahead and export the STL. I'm going to reselect that export feature. And now I'm going to drop down and create a 3MF version. So now I've exported both of those to be sent to a 3D printer. So let's go ahead and look at the comparison of the two different file types. So in the previous step, we created a 3MF and an STL export. As you can see, look at the file size. The 3MF is significantly smaller, more than half the size of the STL file. And again, even with the smaller file size, we're able to maintain both the textures, the surfaces, properties of the model, as well as the colors. So the 3MF file is the much preferred 3D printing file type. but maybe some older 3D printing options actually can only handle STL file type. So this is something to keep in mind based on the configuration of your 3D model. So now that we've explored all of the 3D features within the command bar, we're going to explore some additional features that we can locate from the Solid Edge application button. So ST10 and beyond, we did have 3D printing capabilities. We just didn't have the new 3D printing tab in the Solid Edge environment. So this may look a little familiar with you if you have some experience with 3D printing within Solid Edge, but we'll go ahead and kind of explore this as well. So select the 3D print tab here. This is going to generate our 3D printing interface. So to explore a little bit of this, so here is another area that we can select to export the model. So we can do, this is just another location. So again, we can select 3MF or STL and then export it as previously done in last step. We're going to create 3MF. And then just to kind of show you, we have some settings. So we have it set to 3MF. And then we have options associated to just the 3MF file type. So we can go in and set some additional parameters based on our requirements. And if I back this up and go back into the STL file format, go into options, and now you can see these are options specifically for the STL format. So we have options and configuration parameters that we can set for either one of these. Again, binary is the most common as it's a smaller file type than the ASC2, but we're gonna go back to the 3MF file for this exercise. Catch up here. So printer size. So this is also where we can select our print size or our printer bed size. This is probably a common home use, but if we're in an industrial field, we probably, let's say we have a 2500 millimeter bed. So you can see that this is a very small part being built within a very large bed. So if we had to duplicate several of these, if we wanted to print out 10 for prototyping purposes, we could do that here fairly easily, but we'll get into that a little later. I'll go ahead and set this back to its original default size. I think it was 255 maybe. And again, this window works just like Solid Edge. You can all your zoom, pan, rotate, all of those features are still the same within this field here. And it gives you some volume and surface area of the model itself in the information tab. Now we're going to explore the 3D print section. So this is where you're going to associate or attach a 3D printer that you have on site. Unfortunately, we don't have one available for this exercise, so we'll still explore the options. So we'll go ahead and select 3D print. And this is going to take us into the 3D printing module. So as you can see, we now have the ability to view this in another environment. Again, we can move this thing around and manipulate it as we need it. So this is just giving us a preview of how it's going to be associated. And again, it kind of reverts back to that original orientation. So we can under the material, we can select what type of material we want to be using for the 3D print. And again, this is going to be determined by the 3D printer that you physically have. There are some new 3D printers that can combine materials and colors, so we have the multicolor option if we wanted that. And we can just select some default colors if we want out of the pull down here. And then we can go into the layout. So thin wall detection, this pops up every time, so it's just a warning letting you know that due to some thin wall options, some 3D printers do not have that capability, but we can explore that a little later. So now we can kind of go in here and readjust this part as required. And again, for the last couple of steps, we reorientated this. We knew that this is the best position to be printed. And we can kind of just move this and drag it around. It auto-orientates the view for you. We kind of want it in this bottom hand corner here. And then about. So those are the three features here. And again, unfortunately, we don't have a 3D printer physically attached here, so it's given us the option to do an online 3D print, which is something we'll explore next. So now we're going to look at a really cool feature within Solid Edge. So now we have the ability to order parts online. So if you don't have a 3D printer, or maybe your 3D printer isn't working or acting up, or maybe it just doesn't print the type of material that you want. So now we have the option to go to order online. And we'll go ahead and select that now. So it's important to keep in mind that most 3D prints are usually used for prototyping purposes, so you may have some intellectual property that you may want to protect. So I would suggest you read through the privacy statement here. This is basically going to explain how your information is being shared and whether it's being accessed or secured. So I would thoroughly read through this before accepting to send your information out on the web that could be possibly accessed by others. So read that thoroughly, and if you have some NDAs or non-disclosure agreements that you need to establish or have already established, this is where you would understand those terms and conditions. Okay, now that the part has been calculated and analyzed, you can see now here below we have several different options here. So we can sort all of these different options. So these are different suppliers and vendors that can produce this part. And again, it gives you a price range per part based on the type of material. So for this example, this polyamide is the material selected, and you can get this part from anywhere from $134 to $217,000. So again, this is kind of just a guesstimate based on the geometry of the part that you've selected. I'm going to select by price. Usually price is the most important thing here. So we can kind of scroll through and get an idea of different suppliers and different materials, and then also our lead time. So our lead time and cost is pretty much the most important things to us when we're establishing some prototypes. So this is a very, very cool option built into Solid Edge that gives you some real flexibility if you don't have the capital or operating costs to secure your own 3D printer. This is another good option. And again, I'm sure these prices are adjustable based on the quantity and types of materials. And I'm sure we've got it currently defaulted to a 3MF file. Maybe if you selected the STL file type, this may drive the price down even more. So it's all based on your need. But again, very flexible and very easy to utilize. So finally, we're going to look at the 3D Builder. This is a Microsoft platform. So if you have a 3D printer on site that is Windows based, this will integrate and communicate directly to that pretty easily. So this may be an option for you to utilize some additional features based on your 3D printer that you have on site. So this is a great tool if you needed to add additional features to the geometry to support the 3D printing. As we discussed previously, this orientation may not be ideal for 3D printing to get this bottom face here to start building there. So you may need to create some lattice or other structures here to support that if you're in desperate need to print that in this orientation. So we can go through some couple of features here. You can create some cubes, cylinders, cones, spheres, whatever your recommendation is for supporting this model a little better. This is where you would create that. And again, we have a couple of options here. We can measure the part. Let's do a height measurement. And once that measurement is applied, you can look up here and it gives you the distance in the top left-hand corner here. And again, it's pretty simple. It can snap the features in the part. So if we want an overall length dimension, we see it's 220. We've got the overall height. So again, pretty user-friendly here. We also have the ability to go ahead and move this part around to get it where we need it to go. And if we, for some reason, had to lift it up, we do have the settle command here to settle it back into position. We'll select that. We can also add some features to the part here. We can smooth it. We can create an emboss. We do have some alternate features in here that you may need to create as you're going along the process. We can also create textures and colors to the part and also add a specific material. So that's the 3D Builder. We'll go ahead and close this. We're not making any changes. We're going to discard the scene. So here you can save specific scenes and orientations to test and print out different formatting. This concludes our demonstration for the 3D print additive manufacturing improvements within Solid Edge 2020. I hope you'll have a great day. Thank you.